Hello guys, and welcome to another Unity video. In this video we will be discussing linear drag as part of the Rigidbody 2D component. So linear drag applies to the positional movement of an object, and drag itself is a tendency of an object to slow down due to friction. So this could be friction due to air, due to friction of water, or due to some type of system that slows down the object, right? So in this scene here, this project, we have a rocket that we want to safely land. And if we don't apply linear drag to this object, it's just gonna go ahead and fall straight down. But what we want to do is we want to safely land the object. So what we typically would do is apply drag to the object. Just as when people jump off a plane and use a parachute, we want to mimic that same type of experience here. So if I were to go ahead and play and I don't apply drag, then the object is just going to fall straight down. And without some type of way to actually land the object more naturally, we will end up destroying the object. However, if we want to land it more naturally, what we can do is apply drag to the object, and by applying the boosters to the rocket, we can safely land the rocket down. So this project is just going to be showing you guys how to use linear drag in script. In this project, we have our rocket, which has a sprite renderer component and a capsule collider 2D. And then we have a particle system, which is the rocket thruster, which is going to be used to simulate the landing of this rocket in a more natural way. And the next thing we need to do is create a script that's going to go ahead and put this together. Let's go ahead and name it as linear drag, and let's open this up. What we're going to need is the Rigidbody 2D component. And then we need to go ahead and create some variables. Alright, so the variables that we need are the rigid body on the object. We need a key code to simulate starting the drag on the object. And then we need an interpolation value for the drag, initial start value, and the end value. The reason is because when you drop an object, their initial speed stabilizes over time. So we need to create that experience. The next thing we want to do is create an interpolation value. This is going to tell us what constant we need to add to our beginning value and our end value, so that we start and end from the beginning value and the end drag value. And then our interpolation drag value is going to tell us when to interpolate these two values over time and when to stop. And then the raycast is going to be used, the offset is going to be used because when we shoot a raycast down from the rocket, it hits the collider on the actual rocket. So we need to create an offset for that so that we actually hit down and not hit on that collider. So the next thing that we want to do is start initializing things. Alright, so we need a void start. So for this, what we need to do is for our rigid body, we need to get that. Component, rigid body 2D. And then we need to get our thruster. So the thruster, which I forgot to create, is going to be, let's make this. Alright, so the thruster is going to be the transform of this object, the get child, and we're getting the only child, and we want to make sure that it's a game object. And then what we need to do is set our interpolation drag value to false at the initial stages, and then we need to make sure that we set the M thruster to inactive, set active to false. Alright, so now that we're done with this, let's go ahead and create an update function. Do update. Alright, so in our update function, the first thing we want to do is make sure that we press the spacebar to simulate drag. So we're going to say that if input dot get key down, and we pass in the spacebar. I mean, you can pick any key you want, but I'm going to use the spacebar for this. What we want to do is set our interpolation value to true. So we're going to do M interpolation value is going to be equal to true. So we can actually start interpolating between the two values. Alright, so if our interpolation value is true, then we're going to go ahead and set our drag. So we're going to say that M RB dot drag is going to equal to matf dot lerp, and we want to lerp from our M linear start value to the end value. And then we're going to pass in our interpolation value. Alright. Now what we need to do is make sure that we calculate the interpolation value, which is going to plus equal to time dot data time times 0.5f. You can change this, it's up to you. You can make it to a bigger value if you want it to be a lot faster. And then what we want to do is set M thruster back to active. So we'll do M thruster set active to true. And also we're going to say that if our interpolation value is greater than let's make it 99f, then let's go ahead and set let's set the interpolate drag value to false. So interpolate drag value goes to false. So just tell it, hey, stop doing this calculation here. So let's go ahead and add this to our game object and see what this does so far. Alright, so what we're going to do is drag the script to our rocket, drop this here, and what we want to do is get the spacebar here. You can set this to 12 and this to 20, and here initial drag value, you can put this wherever you want, it doesn't really matter, and this gets auto populated on its own. So once we go ahead here and hit the play button, this should just go ahead and fall, and you can see that the thruster on the object got disabled. Alright, so let's do that again, but this time let's go ahead and hit the space bar, and you guys can see that the value here, right, went up to 999. And if we were to go ahead and look at our drag value on the rigid body, you can actually see that it's closer to the 20. So let's stop this again, hit play, and you guys can see that the value here gradually changed. So this meant that we went from falling faster to coming to a more stable value. So you can change this value, the end value, to what you want, and then add the range of the interpolation to anything over 1. So when it reaches 1, this is going to be the exact value. But you guys can see that we still have the thruster on, and what we want to do is turn off the thruster once it hits the ground, or when it gets close enough to the ground to land. So let's stop this. Let's go back into our code, and what we're going to do is add another Unity function in here. This is going to be a fixed update, and in the fixed update, what we're going to do is use a raycast hit. So we're going to do a raycast hit 2D, call it hit. It's going to be equal to physics 2D dot raycast, and for this we're going to pass in the transform dot position, and then we're going to pass in vector 3 dot down and multiply that by 10f. Alright, so this is just going to be the direction, and we're going to say that if hit, so if we hit something, alright, so if we hit something, then what we want to do is figure out what the distance is from that thing and see if we're going to turn off our thrusters or not. In this case, there's other one thing that we're going to hit, and that is the grid, right? So in this case, what I'm going to do is let's do a debug dot draw line, and we're going to pass in the transform dot position, and we're going to pass in vector 3 dot down times 10f. So pretty much doing the same thing that we did up. Alright, so in this case we're going to say that if vector 3 dot distance, so this is going to be the distance from the hit position, or hit point, so whatever it hits, and then the transform dot position, which is going to be that of our object, and if that is less than or equal to 1f, that means that we're closer to the ground. So we're going to go ahead and set our M thruster to inactive, and we're also going to set our interpolation value to inactive. So that means that we're in the ground, we don't have to keep interpolating it. So we're going to set that to false as well. Alright, let's go ahead and go back into Unity, and let's hit play. But now when I hit the spacebar, you guys can see that the particle system tries to show, but it's not longer showing, right? And if we add a debug statement here, you would clearly tell, and this is something that I've had with many other projects, is that the raycast goes from the center of that object, and when it hits anything underneath that object, right, it reports it. but what is hitting is the actual collider on the object. So what we want to do is we actually want to set the raycast to not start from the center of the object or somewhere underneath where the collider on the object is. So let's go back into our code, and that's the reason why we had this raycast offset here. So what we're going to do is we're going to say, hey, instead of you just starting from the transformer position, start from the transformer position plus the raycast offset. And we're going to do the same thing with the draw. So I'm going to do M raycast offset. So once we go back now, we can go back to our raycast offset and let's make this negative. Make this negative 1. Make this negative 88. And now, when we actually run it, you can see that if I press this, now the raycast starts underneath the object. So once it gets down to a certain point, it should stop right there. Alright, so you can even tweak this a little bit more. So let's make this, I don't know, like a 70. What I was going to initially do was play with the lifetime of the particle, but then I figured that was too much for this. Alright, so that works. Anyway, this will be it for this project. I hope you guys enjoy it. I will see you guys in the next one. If you haven't subscribed to the channel yet, please do so. And have a good day. Bye bye.